Alright, so we left off with cyclic compounds. So let's look at some examples of cyclic compounds. Before we start, if a compound has side groups to it, and the side groups are on adjacent carbons, then you call it ortho, and you can abbreviate that with an O. If the side groups are on carbons that have one carbon in between, then it's called meta, and you can abbreviate that M. Finally, if it's completely opposite of each other, then it's called para, and you can abbreviate that with a P. So those are some abbreviations on where to put side groups if there are side groups. Alright, so for example, if we have this structure, where we have hydrogens coming off all of those carbons so that they have 4 bonds. Our longest chain of carbons would be the cyclic compound. We have 2 side groups coming off. Notice that they have one in between. The first side group is a methyl because it's just CH3. The second group is a little different. You have a chain of 3 carbons, and it wouldn't matter how you would count that. And you have a methyl group coming off of that chain of carbons. Well, Alright, so we have 4 carbons, but a chain of 3. Because there is a chain of 3 with one side group coming off of it, it gets the name tert, butyl. So the butyl is telling us that there's 4 carbons. The tert is saying that there's a chain of 3 carbons. Now that side carbon would be coming off of the first one. That side group would be coming off of our first carbon in our circle. Then our next side group would come on the third carbon. So then we would say 3, and that's a methyl group, so we would say methyl. Now why did I start with this side group first is just alphabetical. B comes before M in the alphabet. Then we have a chain, a circle, so we'd say cyclo. It's 5 carbons, so we would say pent, and they're all single bonds, so ane. Alright, if we look at another one, alright, here we have 2 side groups. We have a methyl group and a bromine group. Now if you recognize this ring, there's 6. The circle in the middle represents 3 double bonds that could rotate between them, so it's like putting the 2 resonance structures together. So that's benzene. Now I have a methyl group and a bromine group. Notice that they're in the meta positions because there's a carbon in between. So we could call this meta, and then alphabetically bromo, methyl, benzene. If we wanted to name it the longer way, we could say 1 bromo for the first carbon. That would put the methyl group on the third carbon. So that's what meta is doing for us, is telling us the 1 and the 3. And then it's a circle, so it's hexo. It's made of 6 carbons. So we would say hex, and then we have the double bonds, so we'd say ene, hexene. Alright, there are also functional groups. Functional groups are very special side groups that change the properties of the carbon. So you could have a halocarbon, and we've already talked about those with the chlorine and the fluorine and the bromine. Halo meaning halogen. So you have your chain of carbons, which is what the R stands for, and then you have that side group. An alcohol, you have a chain of carbons, and then you have an OH group. Now when you name it, instead of ending it with ANE, ENE, or YNE, you would end it with OL to represent the alcohol. An ether, you have a chain of carbons, but in the middle of the chain you have an oxygen, so it kind of disrupts the chain. That's an ether. So at the end of the word you would actually put the word ether. An aldehyde, you have your chain of carbon, and the very last carbon has a double bonded oxygen with a hydrogen. And aldehydes end in AL. Alright, so for example, if we have iodomethane, meth means one carbon, iode refers to iodine, and then I would have my 3 hydrogens. If it says methanol, the OL is telling me that there's an alcohol. So I would have my 1 carbon because of meth, I would have my alcohol group, OH, and then I would have my other 3 hydrogens. If I had this chain, I have 2 methyl groups with an oxygen in between, so that's an ether. So I have 2 methyls, dimethyl, ether. And then if I had, let's say, I'm sorry, I wrote that wrong. Alright, let's try this one. If I had a seed like that, I have 1 carbon, so that's methyl, or meth. I have this double bonded oxygen, so it's an aldehyde. So this is methanol. The generic name actually for this compound is formaldehyde. So there's your analdehyde, and then it's 1 carbon. So that's just a generic name. So like benzene we know is a 6-sided ring with double bonds. Formaldehyde we should recognize as CH2O. Some other functional groups that we have, ketones, the double bonded oxygen is in the middle of the chain and ends in ONE. Carboxyl acids, the last carbon has a double bonded oxygen and an alcohol group, and so it ends in OIC. IC referring to the acid part. And ester, you have a chain of carbons, and in the middle of the chain you have a double bonded oxygen and an oxygen in the middle of the chain, so it ends in OATE. And then an amine is any time at the end of the chain, instead of having carbon or oxygen, you have a nitrogen group, and you use the prefix amino there instead of changing the ending of the name. Alright, so some examples. If we have propanone, prop means 3. Because it ends in ONE, it tells me that it's a ketone. So in the middle of the chain, I have to have a double bonded oxygen. Now, this one is actually a special one. This is actually acetone. So if what you clean your fingernails with would be acetone. Another way to show this, because I have a methyl group on either side of my ketone, you could also call this dimethyl ketone because of the symmetry there. Let's see another example. If we say ethanoic acid, you would have your chain of carbons, and then at the end of the carbon you would have a double bonded oxygen and then your OH group. So what we have is CH3COOH, and hopefully you recognize that as actually acetic acid. So some of these organic compounds can be named different ways, and so there's generic names, and then there's the organic way of naming it. All right, let's do one more. CH3, COOCH2, CH3. All right, so if we break that down, we have carbon with 3 hydrogens bonded to a carbon that's bonded to an oxygen that's bonded to another oxygen that's bonded to a carbon with 2 hydrogens, and then our last carbon. So our functional group is this piece right here. So hopefully you recognize that as an ester. On this side we have a methyl group, and on this side we have an ethyl group. So we could call this ethyl acetate. If you have CH3 NH2, you have a carbon with a nitrogen that's bonded to 2 hydrogens, and then it would have 3 hydrogens coming off of the carbon. You have 1 carbon and you have an amino group because of the nitrogen. So that would be amino methane. You could also flip that and call it methylamine. So that's just looking at it going back the other direction. So some of the common names: ethane, ethylene, propene, propylene. 2-methylbutane is also called isopentane. Iso means the same 2 methyl groups coming from the branch on the second carbon. 2,2-dimethylpropene, neopentene. So the neo just means that it's a 2-sided group. You have groups, 2 methyl groups on either side of the propane chain, prop meaning 3. And so our carbons would be on either side like that. Iso, it's just on the one side, so bute means 4 carbons. And then you have the 2 methyl groups, and they would be coming off of the same side. These are isomers. Isomers just mean we have the same number of carbons, but they're structurally different. Alright, so if we work some examples, or let's look at some more examples. It takes some getting used to all the different naming systems. So hopefully you recognize this again as benzene, and then we have a chlorine side group, and then hopefully you recognize this functional group as carboxyl acid, because you have the double bonded carbon with the OH group on the side. So you want to number it so that they're on opposite sides, so you could call this pero, and then alphabetically chloro would come first, and then you have your carboxyl acid group. So we're going to take the name of benzene and change it to OIC, so we have benzoic acid. If we look at again, we have that carboxyl group right here, carboxyl acid. We would definitely want that in the chain of carbons that we have. So if we number it, we could say 1, 2, 3, 4, 5, come down 4, 5, 6. So actually the longest chain would be 6 carbons. You could number it back the other way, but we want our functional groups to be on the lowest carbons possible. So this direction would make the most sense. So we have a carboxyl group, we also have a methyl group, and we have an ethyl group. So we want to do this alphabetically. So the ethyl group is on the third carbon. On the second carbon we have our methyl group. Hex for the 6 carbons in the chain, and then we want to change the ending to show the carboxyl acid group, so hexanoic acid. Alright, one more. Alright, so we want to have the longest chain of carbons possible, and we want our side groups to be on the lowest possible. Here we have a double bonded oxygen at the end of the chain, so we probably want to start numbering the chain actually there. So that would be 1 carbon, 2 carbons. I could go down, but that would end my chain. So I'm going to go over to 3. I could go down 1 more carbon, or if I go up, I can get 2 more carbons. So that would be our longest chain there. So our longest chain is 5 carbons. And then we have a side group here and a side group here. Both of those side groups are methyls. So we have it on the second carbon and the third carbon, 2 methyls, dimethyl, and then our longest chain is pent. My functional group would change the ending to pentanol. Practice, practice, practice.